Hi there, welcome back everyone. It's been a while and I haven't made a video in about a week. So let's get started. So basically what we've done so far is our first week we had an introduction to GIS, went through the basics of how to import vector files. And the second part, GIS2, which is actually practical number 7 of AGE1002S, is going to go a little step further. So now we're going to generate information and we're going to add information to our GIS program. As I mentioned in Practical 6 or during Practical 6, when you're using QGIS, I think the best thing to go about is to play with it. Go through all the different buttons, press on the buttons, have your data when you import your data, look at them, play a little bit with the symbology, change the symbology, in other words, change how it looks. You do those things. Import different shapefiles, see how they look. And then also crucially, when you have your vector data, make sure that you put your polygons right at the bottom, and then you put your line data on top, and then you put on your point data. So there is a bit of a hierarchy there, and the reason for that is because your polygons are basically almost like an opaque layer. So if you put those vectors on top, then you won't be able to see anything underneath that. So just keep that in mind. It's just like just something in the back of your mind when you are dealing with vector data. And the same is true for raster as well. If you have a raster file or a raster layer, if that goes right on top, that's the only thing you're going to see because it's completely opaque. Now there are ways where you can actually circumvent it by changing the transparency of these layers. You can make them more transparent, which means you kind of take away that issue. But just best practice, I would suggest using that hierarchy. So your polygon's right at the bottom, then you put your lines, and then you put your points. And obviously when you start dealing with raster images, your rasters are always smack at the bottom. So let's quickly look at Practical 7. So what I'm going to do is, I think for Practical 7, I think we're just going to have a quick look through what exactly Practical 7 is about, and then we'll have a little bit of just a quick demo. Now remember, similar to the previous practical, I don't want to give you the answer, so I'll veer off a little bit and do something slightly different, because I want you to practice on your own and I want you to follow the instructions as they are given to you, and find the answers yourself. Also, one of the things that you'll discover with QGIS is that it can be temperamental. Sometimes features just don't seem to work as they should. And it's just one of those things, right? It's just one of those things when you're dealing with software. Sometimes things just don't want to work. And we saw that during the prac last week as well, where we had a few things that we had to troubleshoot on the day. So basically, what's happening in Practical 7 or GIS number 2? Basically, we had a look at latitude and longitude, and I gave a bit of a presentation in terms of what exactly is meant by latitude and longitude. I'm not going to go through that again. You can go through my practical PowerPoint presentation if you really want to know a bit more about it. But here you do have a fairly good summary about latitude and longitude, which if I were you, I'd definitely go through again. For the task that you're going to do is, obviously you're going to try to find the latitude and longitude for the University of Cape Town. You want to know whether or not it's north or south of the equator or east or west from the prime meridian. And then thereafter, you're going to then put this information into UTM. There's definitely a way to convert between the two. The mathematics is not that difficult. So for this task, you basically use the latitude and longitude that you've gotten from Google, and then you're going to put that into this website, and it will actually calculate your standard UTM. Unfortunately, this link does not work anymore, so we are going to use a slightly different one, and I'm going to put that up in a second. But we're just going to run through the prac just to give you an idea of what exactly we're going to be doing. The other part of this is we're going to create a CSV file. A CSV file is basically just a text file, which is basically a comma separated file, and you use it in Excel quite a lot actually, using data. And the easiest way to do that is through Excel. In Excel, you can actually save the files as CSVs as well. You can actually save any data point or any data that you have in Excel as a CSV. It's probably one of the easiest ways to save data, and the files are generally fairly small. So if you have a big data set, saving it as a CSV file is actually not a bad idea. But most people will actually save it with the extension XLS, which is your standard Excel format or file format. So these are the burial mounds at Sutton Hoo. Now, if you've done a little bit of research on Sutton Hoo, it's actually quite interesting, because these are medieval aged burial mounds, and at these burial mounds they found a number of very interesting artifacts from the Middle Ages. So from the medieval age actually. So please have a look at that. Maybe read up on it, and maybe this prac will give you a little bit more. It will actually add to the experience. So you're actually dealing with real archaeological data. Then thereafter, we're going to use the CSV file, or use the CSV file that you're going to create in Excel, and we're going to import that into QGIS with the data set that we already have. You should end up with something looking like this, and then we're going to add additional data, and that's what you're going to be using. All right, so the first thing I want to do is, let's just first do the Rondebosch thing quickly. So if I go to my browser, I've got my browser set up, and so I want to go and look for Rondebosch. And I also want to have Rondebosch coordinates. And there we go. So you'll notice that it actually shows our latitude is 33.9636 degrees south, and our longitude is 18.4763 degrees east. I just quickly want to mention about latitude and longitude. Latitude and longitude, you can actually find it in very different formats. So sometimes you'll find it in this format, which is basically just your degrees format with a decimal, or you can find it in a different way, which is degrees, minutes, and seconds. And so let me just quickly see if I can do that. So if I go to Rondebosch coordinates and I say degrees, minutes, seconds, let's just see if we go here, Rondebosch, and here we go. So there we go, Rondebosch, and we just quickly go down here. So that is, there's our latitude and longitude, and then also this is the DMS, in other words, degrees, minutes, and latitude for Rondebosch. So it's 33 degrees, 57 minutes, 56.8368 seconds south. So these two are the same. The conversion between the two, very easy. It's something that if you want me to, we can do in class. And then also when we go here, this is DMS longitude, obviously this one here, 18 degrees, 28 minutes, 51.672 seconds east. So that's one way to go about it. And then also you'll notice the second question is given as well. You have our UTM easting and UTM northing as well, and in the zone in which we are in terms of UTM. So theoretically you can use this website as well. I personally like this one, and I'll make the link available to you, because if you look at it and you just scroll down, it gives you the option of doing decimal degrees, right? Okay, so latitude, longitude, you can write it in the degree format. So it might be 33.6789, or you can do it in degrees minutes, or you can do it degrees, minutes, and seconds. This is a different one. Then you can do it in UTM, and so forth, Gauss-Kruger. So there are different forms that you can apply, different ways that you can actually use this as well. So I like this one actually. I like this method. Well, this website, and I'll make this website available to you. Or you could even use this one as well. Doesn't really matter. So the other thing you want to do is you don't want to stop there, obviously, because the practical is not about Rondebosch. It's not about finding the the latitude and longitude of some point in Rondebosch. You want to find the latitude and longitude of our university, so University of Cape Town. So you want to find that point there. And that I'm not going to do for you. That is something that you need to do by yourself. I've kind of given you a way of going about it, but you have to think about what exactly you need to do. How do you get to University of Cape Town using Google Maps? How to get the latitude and longitude, and then also as the second part to this task, how exactly can you put those values into UTM? And also answer the question, are we south of the equator? Are we north of the equator? Are we east or west of the prime meridian? Okay, so this is the first part of the video, and now we're going to do the second part of the video, which is basically creating the CSV file.